Hello, in this video we're going to be talking about the nature of the roots. Okay, so what are we talking about when we're saying roots? So we have a quadratic equation first of all that we're solving. This is the standard quadratic equation in this form. So when we're solving something like this graphically, what we are finding are the x-intercepts. The x-intercepts. Okay, so we want to know when we're talking about the nature of the root, we're talking about the solutions to such an equation, or graphically we're talking about the x-intercepts, and we want to know what kind of numbers are they. So what we use to solve quadratic equations is we can either factorize if possible, and if not possible, then what we do is we use the quadratic formula over here. So this quadratic formula we use to find the roots of quadratic equations. Okay, now a particular part of this formula controls the nature of the roots, and it is this part over here. Because this here, any real number over any other real number, that will give you a rational number. But because this is a square root, depending whether this is a perfect square, non-perfect square, positive or negative, this would determine the type of number we get, because different numbers under square roots give us different answers. So let us look at that further. So here we've got the determinant. The determinant, as I pointed out before, was b squared minus 4ac, where once again the b is the coefficient of x, the a is coefficient of x squared, and c is our constant term. So we take that from the equation, then what we're going to do is call that the determinant. We denote the determinant with this capital delta. Okay, so let us look at the types of determinants we can get. Okay, so the first one is when the determinant is equal to 0, and then we get rational, real, equal roots. So what does that mean? It means b squared minus 4ac is equal to 0, and when that is equal to 0, then we have a solution that looks like this. So on our quadratic equation, we can see that we have just one solution. In other words, the turning point is the x-intercept. An example of something like that would be x squared minus 4x plus 4. The determinant for this here would be, well, b is minus 4, minus 4 squared minus 4, a is 1, and c is 4. So that is 16 minus 16, which is 0. And if we factorize this, what we get is x minus 2 times x minus 2 is equal to 0. And as we can see, the factors are the same, so the roots are the same. So that's what when delta is equal to 0, we have real, rational, equal roots. The next one is when delta is positive, greater than 0 is also positive. So we have a positive solution. We have then a real unequal root. So the answer looks like this, where as you can see, there are two solutions and they're not the same. Okay, now we can further classify it according to whether delta is a perfect square or not. So if delta is a perfect square, then we're going to have the square root of a perfect square, and that is going to give us a rational answer. Okay, so if delta is positive and a perfect square, we get rational, real, unequal roots. If delta is not a perfect square, then what we get is an irrational solution. Okay, so because what will we have is we'll have a non-perfect square under a square root, which we know is an irrational number. So delta being positive, we know definitely that it is real, we know that it is unequal, and then further we can say whether it's perfect or not, rational or irrational, depending on whether the square is perfect or not. This is how it looks graphically. We have two different solutions. Lastly, we have delta being less than 0 or negative. Okay, so if it is negative, what we get is a non-real root. So graphically, it looks like something like this. Of a negative graph, the maximum is below the x-axis, so it will not cut the x-axis. Or for a positive graph, the minimum is above the x-axis, so it will not cut the x-axis. So can you see there's no intercepts, so there's no real solutions? Why do we get a negative? Because remember, the formula is x is equal to minus b squared plus or minus the square root of the determinant over 2a. That's, remember, that is b squared minus 4ac. So what happens when we have a negative under a square root is then we have a non-real solution. So when delta is negative, we have a non-real root, and it looks like that. It doesn't really cut the x-axis at all. So a quick recap on the stuff. So delta, the determinant, helps us to determine the nature of the root. This is what it is equal to. We get three broad cases where it is equal to 0, and in that case we get real equal root. We have delta being greater than 0, and in this case we get real unequal root. Okay, and this can either be rational if it is a perfect square, or irrational if it is not a perfect square. Lastly, if delta is less than 0, then what we have is a non-real root. Okay, thank you so much for watching this video. Please keep your eyes posted for an example video on nature of roots, where we'll do a few examples. Please add in the comments below what type of sections you'd like to see, or what kind of topics you'd like to learn about. Please subscribe. Tell your friends to subscribe. Anyone who'd benefit from these videos, tell them to subscribe. And thank you again.